Letter A is 15 and 2/3. Letter B is 4 and 2/4, which reduces to 4 and 1/2. Letter C is 4 and 1/6. Letter D is 4 and 2/8, which reduces to 4 and 1/4. How many of you got all of those right? Raise your hand. Wonderful. Section 9 says solve these measurement equations. Letter A is 4. Letter B is 4. How many of you got 100s on your math homework? Wonderful. Put your math homework away. And let's look up at our column addition. Let's see how sharp you can sound today. Remember, when you see a 9, in your head you can add 10 and then subtract 1. Just think 1 less than the number you're on, and it will help you to add the 9s quicker. Here we go. Ready?
2, 6, 15, 24, 27.
Wonderful. Carrying a 2.
2, 10, 19, 28, 30, 39.
Woo, sounding sharp. Carrying a 3.
3, 10, 18, 18, 21, 29.
Carrying a 2.
2, 10, 16, 25, 32, 34.
Good. Carrying a 3.
3, 5, 10, 19, 27, 32.
And remember what we can do to read a number like this. Cover up this part, read the number, and then that comma represents thousands. Read the second number. Nathan, read the number for me.
324,997.
Excellent. We're going to look over here at our 1 through 100 chart, and we're going to say our 7 times tables like this. 7 times 1 equals 7. 7 times 2 equals 14. 7 times 3, you get the idea. Here we go. Say it with me.
7 times 1 equals 7. 7 times 2 equals 14. 7 times 3 equals 21. 7 times 4 equals 28. 7 times 5 equals 35. 7 times 6 equals 42. 7 times 7 equals 49. 7 times 8 equals 56. 7 times 9 equals 63. 7 times 10 equals 70. 7 times 11 equals 77. 7 times 12 equals 84.
Very good. Now that we've gone through the 7 times tables, let's see if you can just count by 7s up to 84. Here we go. Ready?
7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84.
Good. You're thinking this morning, and I like it. All right, let's see who can answer quickly. Everybody's answering all together right now. Ready?
5, 49, 56, 42, 14, 10, 17, 16, 4, 7.
All right, here's some division. Here we go.
5, 3, 7, 1, 0, 8, 7, 4, 9, 6.
6. I was just about to say we sound perfect, but then we messed up the last one. Let's try it again. Ready? 54
Divided by 9 equals 6.
All right. I was listening for some sharp-sounding people. Isaiah, you are sounding awfully sharp. So come be our Speedy Sam. And then I need a girl to just beat Isaiah very badly. Lois, I want you to try. So Lois, you come on up. Go back to back with Isaiah. Now take small steps so our students watching can see you. All right, here we go. 9 times 7 plus 3 divided by 6 times 10 plus 5 equals
115.
Good job, Isaiah. All right, Nathan, it's time to smoke them. Here we go. 5 times 6 minus 5 divided by 5 times 2 times 10 equals
100.
100 is correct. Good job, Nathan. Gage. Now I have a question before I give you this one. This might help you. When we multiply something times 10, all we're really doing is adding what on the end of the number, Gage?
A 0.
A 0. All right, let's see if you can do this one. This got some big numbers in it. 100 divided by 2 times 10 divided by 2 equals.
250.
Good job, Nathan. That was a hard one. Parker. 6 times 9 plus 6 equals.
650.
Good. Mid-high. 72 divided by 8 times 8 minus 1 equals.
63. 75.
Kenton?
71.
71 is correct. Riley, come on up. And Gabrielle, come on up. All right, girls, you can do it. 15 divided by 5 times 9 minus 3 plus 1 times 4 equals. Kenton? Lois?
120.
Students watching? It's 100. Let's try one more. Girls, come back to back. This is a long one. Remember what you do with tens. 9 times 8 divided by 9 times 8 plus 6 divided by 10 times 7 plus 1 equals.
50.
Good job, Riley. All right, let's see how many facts we can answer. Who can tell me how much a metric ton is? Parker?
2,200 pounds.
And how many grams are in a kilogram? Jay?
1,000.
All right, let's answer all together. Ready?
1 pound equals 16 ounces. 1 minute equals 60 seconds. 1 millennium equals 1,000 years. 1 pint equals 2 cups. 1 meter equals 100 centimeters. 1 mile equals 1,760 yards. 1 century equals 100 years.
All right, Layla, you're working hard. Layla, come next to Lawrence. Here we go. Who knows their facts the best? Ready?
20.
Layla. All right, ready, Sierra?
3.
Yeah. Oh, she was ready.
12.
Gage.
366.
Riley. Everybody's moving back a seat. Here we go.
4.
Riley.
100.
I'll give you another one.
1,000. 10.
10.
2.
Riley.
12.
Peniel.
10,000.
Paige.
10.
Paige. Paige, come against your friends watching.
5,280.
Oh, they beat you so badly, Paige. Here we go. One more.
7.
Good. Come against Rayanne.
8.
Rayanne.
24.
Kenton.
62.
Kenton.
2,200 pounds.
Kenton.
1,000.
Kenton.
20. 10.
Kalani.
2,000.
Good.
10.
Kalani.
365.
Nathan. Smoked you, Kalani.
About 52.
Isaiah.
33.
Isaiah.
1,000.
Isaiah.
8. 4.
4. And come against your friends watching.
8.
Woo, that was fast.
16.
A little louder. One more.
60.
Very good. Go back to your normal seats. I have mixed together some proper fractions and some improper fractions. If you see a proper fraction, which means what? Rayanne, a proper fraction is?
The numerator is less than the denominator.
Good. If you see a proper fraction, clap twice. If you see an improper fraction, I want you to make it completely quiet in here. Okay, improper fractions, we don't give them the time of day. Here we go. Ready? Good. Clap twice. It's a mixed number. We shouldn't be clapping. Here we go. Ready? Good. Good, it's quiet. Parker. Good. Jay, improper over there. Quiet. All right, here we go. Good. I'm glad it was quiet. Now, Gage, can you change this improper fraction to a mixed number?
Four and 4/5.
Good. Paige, this one's for you. Change it to a mixed number.
7, 8, and 2/9.
Good. And Kenton, reduce this fraction. And Heinz?
2/3.
Oh, got it right at the last second. 2/3 is correct. Go ahead and prepare for a speed drill. Should be the last one on the page today. You have 2 minutes. On your mark. Get set. Go. Students watching, go ahead and stop that speed drill and put it away. Hope you got every single one of those boxes right. If we look up here at my easel, I see a true statement. 2/4 equals 1/2. Now, if you look, here is 2/4. If my circle was divided into 4 pieces, these are 2 out of the 4 pieces, and 1/2. These are the same size, so we can see that they're equal. We can also know they're equal because if I reduce 2/4 and I divide it by 2, 2 divided by 2 is 1. 4 divided by 2 is 2. So is it true to say that 2/4 equals 1/2? Yes. We would say that 2/4 and 1/2 are equivalent fractions. That means that they're exactly equal. Now, if this is true, 2/4 equals 1/2, I have a question. Is this true? Is it true to say that 1/2 equals 2/4? Yes. Because, I have a question, are they still the same amount? Yes, they're still the same amount. I could switch the sides. I could put my 1/2 over here, and I could put my 2/4 over here, and it's still the same exact amount. Nothing has changed. The only thing I've done is I've flopped the order that the fractions are in. But 1/2 and 2/4 are still the same amount. Now watch this. Are you ready to really get those thinking wheels rolling in your head? If I divide from 2/4 to get 1/2, I divide it by 2. What do you think I would have to do down here to change 1/2 to 2/4. If I divide up here and I'm doing the opposite, then what would I do? Multiply. Watch this. If I multiplied 1/2 times 2, 1 times 2 is 2. 2 times 2 is 4. I did the same thing, I just flipped it. So up here I divided to make it smaller. To make it bigger, I multiplied. But the key is it has to be the same number. In order for it to be equivalent fractions, to be equal, it has to be the same thing. I think of it this way. My grandmother, on my dad's side, she's extremely fair. And for Christmas, she always makes sure we all get the same exact amount of presents. One time, we all got dresses when we were about this age, 4th grade. My oldest sister got a dress, my youngest sister got a dress, and I got a dress. Except I got a dress and a movie. And you say, Miss Answell, why? Well, because my dress was on sale. She wanted to make sure she spent the same exact amount of money. So she found a movie that was the same price so that we would all be equal. You say, was that necessary? Well, to her it was necessary because she wanted to be equal. With equivalent fractions, we have to multiply by the same number for it to be equal. Now, you're going to make equivalent fractions by multiplying. I want you to multiply by 2. Now watch this first one. I have 3/4. So I think in my head, 3 times 2 is what, everybody?
6.
4 times 2 is what?
8.
So an equivalent fraction to 3/4 is 6/8 because I multiplied by the same number. All right, Paige, this one's for you. Multiply by 2.
2/4.
Good. 1 times 2 is 2. 2 times 2 is 4. So 1/2 equals 2/4, just like we saw on the easel just a minute ago. Parker, multiply by 2.
2 6.
Very good. Very fast. Lawrence, multiply by 2.
2 8s.
So I have a question, Lawrence. Is 2/8 equal to 1/4?
Yes.
Yes. We would say they're equivalent fractions. Sierra, by 2.
4 6.
Good. Sierra, is 4/6 equal to 2/3? Yes. Now let's look up here at the chalkboard. Did you know that to make equivalent fractions, you can multiply by any number as long as it's the same number? I'm going to let you pick a number in a minute. Now, pick one that you know the times table for that number. But I can multiply by 1, not really because it wouldn't change the number, by 2, by 4, by 9, by 1,000,000. As long as I multiply the top and the bottom number by the same thing, it doesn't change it. Let's look at this first one. I'm going to pick 3, okay? 3 times 3 is what, class?
9.
9. 4 times 3 is what?
12.
And if it helps you, you can write it like this. So you see that you multiply by the same thing. So I have a question. Is 3/4 and 9/12 equivalent fractions, class? Yes, because I multiply by the same thing. Now pick a number that you know to multiply by. Riley, pick a number.
4.
Okay. Riley, what is 7 times 4?
28.
Good. And Riley, what is 8 times 4?
32.
So Riley is 28/32 equal to 7/8?
Yes.
Yes. Gage, pick a number that you know how to multiply by.
8.
Okay. 2 times 8 is what, Gage?
16.
Good. 5 times 8 is what?
40.
So is 16/40 the same amount as 2/5, Gage?
Yes.
Yes. Now, sometimes we can pick the number and we can make equivalent fractions, but sometimes they pick one of the numbers. So we have to make sure we pick the same number for the top. Let's look at this one. 2/3 equals what over 9? Well, I look at the bottom because they've already done this part, and I think what times 3 equals 9? Parker?
3.
Okay. So in order to make equivalent fractions, I have to use the same number. So if 3 times 3 is 9, Parker, 2 times 3 is what?
6.
Good. So it'd be 6/9. Let's look at this one. 5 6 equals what over 12? Well, what did they multiply to get 12? 6 times what is 12? Students watching? Nathan?
2.
2. So if I multiply by 2 on the bottom, I have to do it on the top. Class, what is 5 times 2?
10.
So I have a question. If I said you can have 10/12 of my candy bar or 5/6 of my candy bar, am I giving you the same amount?
Yes.
Yes, same exact amount. It's just equivalent fractions. One is bigger, looking than the other, but they're the same amount. Look at your worksheet. You've got to use your brain for this first section. But let's first look at the yellow box. If you notice, those circles are divided up into all kinds of different amounts, but they're actually the same amount. The first one is 1/2. The second one is 2/4. The next one is 4/8. The next one is 8/16, but they're all the same exact amount. Now let's look at section 1 together. Write equal for equivalent fractions and write not equal for unequivalent fractions. Let's look at the first one. 3/8, 6/16. Well, let's look at the top first. 3 times what is 6? Kenton?
2.
Okay, so let's try 8